The search for life within our solar system continues unabated. Scientists are following the signs for water, either deep oceans or hot springs where life can evolve. There are exciting candidates to explore: the icy moons of Jupiter, oceans in the sky. Orbiting the giant Jupiter are 3 prime candidates. Ganymede, the largest moon in the solar system. Callisto, once thought to be dead, may harbor a salty ocean. And the active Europa, with its plumes of water erupting into space. The European Space Agency is about to launch a probe to investigate these 3 potential sites. A daring mission called JUICE.
JUICE is the Jupiter Icy Moon Explorer. So it's the first large mission of the Cosmic Vision program of the European Space Agency, and has the objective to study the Jupiter system and 3 of the Galilean moons, 3 icy moons, which are Europa, Galileo, Ganymede, and Callisto.
This mission is of particular importance for the European industry because this is the first time that Europe is going to Jupiter. So we are supporting the European Space Agency and beyond the European scientific community in their endeavor to go to Jupiter and explore Jupiter and their moons.
The scientific objectives of JUICE are multiple. So first of all, we have humanity always pose itself a question: are we alone in the universe? Is there life outside Earth? To respond to this question, first we need to answer to another question: are environments where life can be sustained before going and search for life? And this is one of the main objectives for JUICE, to search if on the environment, on the ocean world of Europa and Ganymede, there are the conditions to sustain life. Now, from the past missions, we know that some of these conditions are fulfilled, and we want to go with JUICE to investigate even deeper and to make sure that these conditions are there. And these conditions are, for example, there is water, there is liquid water, there is a source of energy inside the planets, so there is energy. There are the chemical compounds which are needed to sustain life, the life as we know, so based on carbon. And is a protected, is a stable environment because it's under the crust of the moons. So once these 4 elements are fulfilled, there is the probability that life will be sustained outside Earth is very high. The other objective of JUICE is to study the Jupiter system in its integrality, as seen as a miniaturized solar system, if you want. We have a gas giant with bodies that go around this body, and studying the interaction of the gas giant with these bodies, we can understand better, for example, the development of our solar system, how it was born, how it works, and etc.
So JUICE is a very exciting mission. So we are going to explore Jupiter in details. And in particular, I would like to know whether there are conditions hospitable for life around a gas giant like Jupiter, and we are going to focus that on the 3 icy moons, which are Europa, Ganymede, and Callisto. And we would like to know whether inside those moons there are conditions which are interesting for life, and we are going in particular to explore the liquid water which are underneath the crust of those moons.
In the past, there were other missions that they analyzed the Jupiter system, like Galileo, for example, has given us important information to build the JUICE mission. There is also Cassini that passed by, that we gather a lot of data also from it, and also from observation from Earth, also observation from Hubble, for example, has provided us loads of data which are precious to build JUICE and to build also the profile of the mission, to know what we are going to study.
We have in total 10 scientific instruments on JUICE. And basically we will observe Jupiter and its moons in all possible wavelengths and type of observations that we can do. So we have a number of telescopes in all wavelengths, visible, infrared, ultraviolet. We have a radiometer to sense the atmosphere, the structure of winds of Jupiter and their moons. And we have electric and magnetic sensors. Some of them will be deployed at the tip of a magnetometer boom. So RIME is this big antenna that you see there, deployed just behind us. It is a radar antenna that is working at a very low wavelength, 9 megahertz. So for that to happen, you need a very long piece of antenna that will be able to sound very deep below the surface, the internal structure of the moons, in particular Europa, Callisto and Ganymede. The objective is to try and locate the liquid water ocean that is underneath the icy crust of these moons. As of today, we are still not sure how deep we have to dig, let's say, to find this ocean, and this antenna will help us figure out at which depth we can find this ocean.
At the moment, the nominal science is foreseen to last 4 years. In these 4 years, Jupiter will make all the investigation. It will make some flybys of Europa, flybys of Callisto, and then we'll go into the details of the analysis of Ganymede. We'll stay in orbit around Ganymede for a good part of the Jupiter tour.
JUICE will start its science mission about 6 months prior to entering orbit around Jupiter, making observations as it approaches its destination. Once in the Jovian system, a gravity-assist flyby of Jupiter's largest moon, Ganymede, also the largest moon in the solar system, will help JUICE enter orbit around the gas giant. During its operations, the probe will make 2 flybys of Europa in July 2032. Europa has the strongest evidence of an ocean of liquid water under its icy shell. JUICE will study the moon's active zones, surface composition, geology, and the plasma environment around the moon. A sequence of Callisto flybys will then be used to study this ancient, cratered world that may also harbour a subsurface ocean, but will also change the angle of JUICE's orbit, making it possible to investigate the polar regions of Jupiter. Now that the probe is fully assembled, it has to be thoroughly flight tested to ensure its survivability, because the giant's magnetosphere traps an intense and dangerous radiation environment.
This milestone is very important because here we have the spacecraft. It's integrated, it's ready. We have all the 10 instruments are delivered, are there. All the platform units are there, the antennas is all in place. So the spacecraft is ready for the test campaign to verify finally that everything's work as expected within the performances they are expecting. And this is 1 year from launch. So this is a very important milestone. The spacecraft integrated is there, and we can carry on with the test phase.
So we start first with electromagnetic compatibility test. The goal is to verify that the spacecraft has sufficiently low level of electromagnetic perturbations, because a number of instruments of JUICE will sense electric and magnetic fields at Jupiter, and we do not want the spacecraft to be a source of perturbation for that. After that, we will do a number of mechanical tests. It will be done over summer. Here the goal is to verify that the spacecraft can survive the launch environment that will be imposed by Ariane 5 when we will launch to Jupiter.
It is true that the JUICE spacecraft that we can see on the background is going to be launched in space, meaning that it's not like for aircraft. We can repair something after a couple of hours of working. We need to make sure that before we launch, everything will work properly as expected.
And then there will be additional tests, like a vibration test, including with the solar array, so that will be quite exciting. We have also what we call EMC Test, so to make sure that the spacecraft is quiet from the electromagnetic point of view. It's very important for the science of the mission. And additional tests like a communication between the spacecraft and the ESOC flight control team that will need to control the spacecraft once it flies. So all these tests will take place in the coming 10 months. And after that, hopefully the spacecraft will be declared ready for launch, and we will ship the spacecraft to its final destination on Earth, which is the French Guiana spaceport.
Replicating the environs of space is no easy task here on Earth. At ESA's test center, ESTEC, in the Netherlands, is the Large Space Simulator, which can model the vacuum of space and simulate both the extreme heat and cold of deep space. It is Europe's largest vacuum chamber, and its internal black panels, which are filled with liquid nitrogen, were used to cool the environment down to around -180 degrees Celsius. To test against extreme heat, lamps are used to raise the temperature up to 250 degrees Celsius.
JUICE, in order to fly to Jupiter, will do some gravity assist around several planets, among them the Earth and Venus, which is very close to the Sun. And in fact, all the electronics inside the spacecraft are supposed to work properly in a certain range of temperature, and the thermal design of the JUICE spacecraft aims at protecting this unit from the very harsh environment, cold or hot, for this unit, in order for them to work properly when we will start to do science at the Jupiter Icy Moons.
To reproduce the heat side of space, so when we go close to the Sun, we simulate the Sun. And in order to do so, we have a set of lamps, very powerful lamps, that are reflected in 121 mirrors that can be reconfigured depending on the mission characteristics. And in this case, we simulate the heat of the Sun while the spacecraft goes through Venus. Why Venus? Because the JUICE mission is doing a flyby in Venus before going finally to Jupiter.
Yeah, so when I saw JUICE going to the space simulator, I had a mixed feeling, of course, because it was a very scary moment. It's a little bit like your baby spacecraft, so you're a bit scared that something will go wrong. But at the same time, you know that the team, in particular, the test center people, they know what they are doing, so it's quite a secure activity. So it was a mixed feeling, but you always feel nervous when you see the spacecraft going into the Large Space Simulator.
And in addition to that, we have also some requirements coming from the environment itself of Jupiter, like temperature and radiation. Jupiter is a very aggressive radiation environment that is making the whole design of a spacecraft even more complex.
Jupiter has the largest magnetosphere in the solar system, 18,000 times more powerful than Earth's. In combination with the sulfur dioxide ejected by the Moon, the space around Jupiter is loaded with plasma. The magnetosphere also traps and accelerates particles, forming an intense radiation field that is thousands of times more powerful than Earth's Van Allen belt. The result is a very hazardous environment for spacecraft and potentially humans.
After that, we will also test the propulsion system in order to be sure that it is leak-tight and fully operational when placed into a flight configuration. We will do a second thermal vacuum test in a chamber very close to this facility in October in order to verify in pressure and temperature conditions and full flight configuration that the spacecraft is behaving nominally in all functions. And finally, after having tested the spacecraft in all these variants and environments, we will verify a last time that from a functional perspective, the spacecraft behaves nominally and is ready for shipment to the launch site.
That launch site is Europe's spaceport in Kourou in French Guiana, where the venerable Ariane 5 will lift JUICE into space. It will also be the final launch of the Ariane 5 rocket series, one of the most reliable launch systems, with 112 launches and just 5 partial or complete failures. The Ariane 5 heavy lift vehicle has launched many of the most important space probes, including the Rosetta mission and most recently the Webb Space Telescope. It will be replaced by the Ariane 6 heavy lift booster.
JUICE will be launched next year in 2023 in April, the beginning of April. The launch window will open on the 5th of April and will stay open for about 3 weeks because of celestial mechanics. And then the spacecraft will, before being injected into the transfer orbit to Jupiter, will have to acquire more speed, and we will need to do a certain amount of gravity assist to the inner planets of the solar system. We will do a gravity assist, which will be a first, which will be a Moon-Earth gravity assist. Then there will be a Venus gravity assist, other 2 flybys of Earth, and then will be projected to the insertion orbit to Jupiter for other 2 years. So overall, it will take about 8 years to get to Jupiter.
The gravity assists, 25 in total, will allow the probe to gain the necessary speed to reach its final destinations without consuming the 3,000 kilograms of precious fuel reserved for course corrections and orbital insertions. JUICE will arrive at Jupiter in 2031, followed by a proposed orbital insertion around Ganymede in 2034, all part of the European Cosmic Vision Programme.
The Cosmic Vision Programme has an objective of studying also outer worlds, so it will be complementary to future missions, to mission currently in development, like Plato, like Ariel, like SMILE, and be complementary with the future missions. There will be an Envision for the study of Venus, with Athena, for example, for the study of the universe, with LISA for the study of the gravitational waves. So it will be complementary to have a full and round information on astronomy and planetary science. And it will be also part of the inspiration that the Cosmic Vision Programme wants to transmit to the scientific community and to the public. So JUICE has been developed by a huge industrial consortium to build the spacecraft itself. So in particular, we have Airbus France, which is the main contractor to build the spacecraft, and which is made 95% by European companies. It's about over 100 companies from Europe, and about the 5% of contribution from United States. The JUICE embarks 10 scientific payloads, and the payloads are the contribution from leading funding agency, which are the space agencies. So in particular, we have CNES, there is the Italian Space Agency, DLR, German Space Agency, there is the UK Space Agency, Swedish Space Agency, and we have also contribution on an instrument, another contribution from NASA. as well as from JAXA, and also from the Israeli Space Agency. And each of these scientific consortium is built by other institutions from as well over Europe. So we have also contribution from Austria, from Belgium, from is a European-wide consortium.
Over time, JUICE's orbit around Ganymede will naturally decay. Eventually, there will not be enough propellant to maintain it, and it will make a grazing impact onto the surface in late 2035. JUICE will not be alone in its mission. NASA is also launching a probe to the same local. However, its primary goal will be to study Europa exclusively. The mission is the Europa Clipper. Due for launch 2 years after JUICE, the Europa Clipper will ride a SpaceX Falcon Heavy. This time, the probe will utilize Mars for a gravity assist in 2025, then Earth a year later, arriving in the Jovian system in 2030, a year ahead of JUICE. Due to the harsh radiation environment, the Clipper will not orbit Europa, but instead orbit Jupiter and make multiple passes of Europa, 44 encounters over 3.5 years. Utilizing the other Jovian moons for gravity assists the Clipper, which will adjust its orbit to pass by Europa and various altitudes from 2,700 kilometers to a mere 25 kilometers, where it will be able to pass through the water plumes erupting from the surface. It will carry 9 instruments, including thermal and radar imaging, ultraviolet spectroscopy, and surface dust analyzer.
This allows us to have a mission that's many years long and to collect and transmit lots and lots of data. As Europa orbits Jupiter, it flexes, and we could measure the gravitational change of Europa by encountering Europa at different points in its orbit. On a typical flyby, we would turn on our remote sensing instruments, we would image the surface, we would interrogate the surface with spectroscopy, and we would do the same thing on the way out. And we would essentially rinse and repeat, and do this many, many times until we understand Europa globally.
Because once we have investigated whether life can be sustained in the icy moons in Europa or Ganymede, then there could be other missions that will go to analyze more in depth if life is really there, maybe with penetrators, with rovers, with sample return missions. And one of the objective also of cosmic vision is to be an inspirator for future missions. Also for a sample return, for example, why not on the icy moons of Jupiter?